One short little video before we continue. Because we're often in astronomy dealing with really big numbers, millions, billions, trillions, and because writing out all those zeros make those numbers hard to read. As soon as you get above a billion, I have to start counting zeros to see where I am. And then if you're talking about 100 trillion or a million trillion or a billion trillion, the numbers quickly get unreasonable. That's why we have a way of expressing really large numbers in math and science called scientific notation. Scientific notation is based on the properties of exponents and powers. For example, think about the number 1 million. 1 million is 1 and then 6 zeros, which is the same as 10 times 10 times 10 times 10 times 10 times 10, right? 6 zeros. We can write that number then 1 million as 10 to the 6th power, 6 tens multiplied by one another. I could write 2 million then as 2 times 10 to the 6th. I could write 12 million as 12 times 10 to the 6th. The exponent of the 10 tells you how many zeros to write after the number you just wrote. So a billion is 9 zeros. A billion is 10 to the 9th. A trillion is a million, which is 12 zeros. So a trillion is 10 to the 12th. And if I start talking about how many stars are there in a galaxy? Well, there's 100 billion. What's that? Well, a billion is 10 to the 9th. 100 is 10 to the 2, right? 100 has 2 zeros. So 100 billion is 10 to the 11th, 11 zeros. So suppose we want to calculate the number of stars in the universe. What would that number be? Well, there's 100 billion galaxies in the universe. There's 100 billion stars, more or less, in each galaxy. So 100 billion is 100 times a billion. That's 2 zeros, 9 zeros. That's 11 zeros is 100 billion. 100 billion times 100 billion is 10 to the 11th times 10 to the 11th. And because of the rules for multiplying things with the same exponent, you can just add those exponents together and really quickly get the answer 10 to the 22. As opposed to picking up a calculator and typing in 1 and then 11 zeros and then 1 and then 11 zeros. Scientific notation makes it easy to multiply big numbers because you can just add those exponents together. So 100 billion times 100 billion is 10 to the 11th times 10 to the 11th, which is 10 to the 22. There's also scientific notation that goes the other way with negative exponents. For example, 1 millionth is 10 to the negative 6. 1 divided by 10, divided by 10, divided by 10, divided by 10, 10 times. In astronomy, we're not dealing with little tiny numbers as much. Particle physicists and microbiologists have to deal with really small numbers. In astronomy, we're mostly dealing with really big numbers. So you should be comfortable because you're going to see it in your textbook and in my lectures. When you see a 10 to the whatever, that just tells you how many zeros come after that in your number. Okay. The next thing we'll talk about is the history of the universe in time. In the earlier lecture, we talked about the scope of the universe in space, and in another lecture, we're going to talk about, or the upcoming lecture, we're going to talk about the history of the universe in time to get a sense of the time scales that are relevant for talking about the universe as a whole.